Hello guys, welcome back to another video. In this video we are asked to evaluate this following integral. An integral from 0 to pi ln of sine of x dx. This integral doesn't look that hard at the first sight, but trust me, it is tricky and you need to know some things to evaluate it. Of course, but let me see. Okay, we will rewrite sine of x as sine of x over 2 plus x over 2, and we will get sine of x over 2 cosine of x over 2 plus sine of x over 2 cosine of x over 2. Of course, that's the formula for the addition of the angles of the sine. So this gives us 2 sine x over 2 cosine of x over 2. Alright, so what will we do with this? We will replace this with this, since this is x and this is just the formula for the x, the sine of x. So what do we get? We get an integral from 0 to pi ln of 2 sine x over 2 cosine of x over 2 dx. Alright, what will we do right now? We will split this up into 3 integrals and hope for the best. I mean, it can go wrong with splitting up the integrals ln. Alright, this equals to an integral from 0 to pi ln of 2 plus an integral from 0 to pi, not sine just, but ln of sine of x over 2 plus an integral from 0 to pi ln of cosine of x over 2. Alright, so this is clearly easy. This is just a constant. I won't write it 100 times with the lines. I will just say this is obviously pi ln 2. I mean, yeah, I don't need to write it 100 times. Alright, let's focus on these two. If you notice, this and this looks quite similar, just that this one has x over 2 and this has x. So maybe let's introduce a substitution. Is this one? I don't know, maybe let's call it like x over 2 equals to y. I don't know, something like that. Dx over 2 equals to dy, dx equals to 2y 2 dy. Yeah, I don't know how to differentiate. All right, and now when we plug it in, we get what? For pi we get pi over 2. For 0 we get 0. So this one equals to an integral from 0 to pi over 2 to pi over 2 ln of sine of y dy 2 times. Yeah, 2 times, and now we need to address this one, since it will take more space than usual. Let's just erase this. We don't really need this anymore. Let's introduce a substitution. Like this one looks similar to this, but the trick is to realize that x over 2 can be written as pi over 2 minus t with the substitution. So x over 2 equals to pi over 2 minus y, dx over 2 equals to negative dy, dx equals to negative 2 dy. Alright, when we solve for y, we get pi over 2 minus x over 2. Alright, so what happens here? When we try to solve for y, we get pi over 2 minus x over 2. X is pi, so this is basically 0. When x is pi, when x is 0, we get pi over 2, obviously. So this integral simplifies to what? This one, like this integral, equals to what? We will take negative 2 in the front, from pi over 2, because pi over 2 minus 0 is pi over 2, this is 0, ln cosine of pi over 2 minus y is sine of y, dy. Now we will use the minus to flip the boundaries, and we get to an integral from 0 to pi over 2 ln sine of y dy. Yeah. So what happens now? Let's get back to the let's add those two integrals we have just solved. I mean simplified. Look, they are exactly the same, so we can add them. And when we add two integrals that have the logarithm, they are the same. We will have sine to the second power. That degree of 2 can go out with the property of logarithms and get multiplied by 2. So we get 4 times this integral. All right, so this, like this plus this, and like it gets equal to 4. The integral 4 times integral from 0 to pi over 2 ln of sine of y dy. All right, I don't know why I'm writing it that way, but I guess it's fine. Now we have to realize one thing. This isn't the same like this one because of the boundaries and everything, but you can realize one thing. Okay, let's erase some things so I have more space. I don't know. Let's erase this. We don't really need this anymore. We have derived it. And this. All right. This integral can be written as an integral from 0 to pi over 2 ln sine of x plus an integral from pi over 2 to pi ln of. All right. I'm writing sloppy. Let me erase this. Plus an integral from pi over 2 to pi ln sine of x dx in the both cases. I just forgot it. All right, so you can see that our original integral equals to two integrals. I mean, when split it up. But what's here to realize is that this, like ln of sine is positive on the integral of 0 to pi over 2, and sine is also positive on the integral from pi over 2 to pi. So these two integrals are basically the same. They're both positive on the intervals they are representing. I mean, sine is positive in this area. And this is 0, this is pi. So, yeah. These two integrals are the same. So we can realize that our integral can be split in two. So these two integrals equal one integral. And we have 4 integrals from 0 to pi over 2. So what do you think? Yeah, this integral equals to 2i. Because these two make one, the 4 times this one make 2 of these, since they're all positive. So altogether, let's continue with the evaluation. Our integral equals to pi ln of 2 plus 2i. And don't you remember, it was equal to I. So here, I equals to pi ln of 2 plus 2i. I minus 2i equals to pi ln 2. This equals to negative I equals to pi ln 2. I equals to negative pi ln 2. All right. As you can see, it wasn't that easy. I hope you understood every single step. If you have any questions, write in the comments. Thank you for watching, guys. Like, share, and subscribe if you enjoyed this. Have a nice day, and let's underline this with a red marker. Yeah. See you, guys.